Game of Thrones how each of the Stark children got a direwolf? Well, now is your chance to fulfill your GOT dream. 12,000 years after vanishing from the face of the earth, the direwolf, apex predator of the Ice Age, has now returned. Not through myth, not through magic, but through science. So let's get into this. Colossal Biosciences, known for its audacious attempts at de-extinction, has made history by reviving species long lost to time, the dire wolf. It all started with fossils, specifically a 13,000-year-old tooth and a 72,000-year-old skull recovered from tar pits. Now, these remains still held fragments of dire wolf's DNA, fragile but readable with today's technology. Now, scientists at Colossal Biosciences pieced together the dire wolf's full genome, its complete genetic blueprint, using these ancient DNA samples. They then compared it to modern grey wolves and pinpointed the genes that made the dire wolf unique. Broader skulls, thicker fur, more powerful jaws. I know it all seems very Jurassic Park, but just hold on to your horses.
So de-extinction to us is recreating these phenotypes. So a gray wolf is the closest living relative of a dire wolf. They're genetically really similar, 99.5% similar. And phenotypically, their morphology is also similar, only dire wolves are larger, more muscular, and have these light-colored coats and other things that we can see from the fossils. And so we targeted DNA sequence variants that we believe lead to those traits. And then we edited gray wolf cells to contain those dire wolf DNA variants. And then we cloned those cells and created our dire wolves.
Next, using CRISPR, a revolutionary gene editing tool, scientists spliced those key dire wolf genes into the DNA of gray wolf embryos. They essentially reprogrammed the embryos to grow into creatures with dire wolf traits.
You take an egg cell that is ripe, ready to be fertilized, but not yet fertilized. It's similar to when a woman is going to go through IVF, where you take hormones and it makes a lot of egg cells ripen at the same time, and then you take them and then you fertilize them in addition in a lab. But we're not fertilizing them. Instead, we're taking those ripe egg cells and we're taking out the genetic material that would have come from mom, and we're putting in a whole cell that has mom's and dad's genetic material. That's our edited cell, right?
And then, once edited, the embryos were cloned and implanted into gray wolf surrogates. After several attempts and a few failures, 3 pups were successfully born between late 2024 and early 2025. Named Romulus, Remus and Khaleesi. Now, they represent the first generation of neo-dire wolves. So while it is exciting that these wolves would be roaming the world once again, it has been 12,000 years since they last exited. Many things have changed, and this begs the question, will they be able to find their place?
To de-extinct something would be to bring that evolutionary lineage back into existence, and that would cause a gap where that species there's a gap when it isn't, and now that species exists again. What they've done is use genetic engineering to make a gray wolf superficially resemble a dire wolf, or at least what we think dire wolves might have looked like, because we're not really sure what that is either.
Well, some say it could restore balance, controlling deer and bison populations, healing degraded ecosystems, although critics warn of chaos, disruptions, crossbreeding and even ecological collapse. So beyond science and ecology, there's also ethics. Is de-extinction a noble attempt to undo human damage or a dangerous game of genetic lottery? But Colossal Biosciences isn't stopping here. With plans to expand the dire wolf population and reintroduce them, potentially in collaboration with indigenous communities, the company envisions a future where de-extinction aids both science and sovereignty. Romulus, Remus, Khaleesi. Not just names from legend, but living proof that in the age of extinction, rebirth may be just a genome away. So as we breathe life into the dead, we must ask, just because we can, should we? Thank you so much for watching this video with me, Ishita Mitra. Stay tuned to India Today Global, where we simplify geopolitics for you.